Welcome to another video, and this time we are talking about piecewise functions. And what you see on the screen right now is an example of a piecewise function. It's basically taking two or more graphs and cutting off that graph at a particular area, right? So you can just take a piece of it. So if you look at this example that I have on the page right now, so this part that I'm circling in red, that's actually a parabola. They actually have the equation right here, y equals x squared. And we know an x squared graph looks like a full parabola, something like this. Not perfect, but something like that, right? So this is showing a parabola that basically has been cut off a little bit because we're just talking about a piece of that function, okay? So that's one part. Let me circle another part of this graph. That's the parabola. So let's look at this part over here. This right here is a line, okay? It's like a y equals mx plus b. For this one in particular, it says y equals 10 minus x. Is still a line. But notice how you have a closed dot on one end and an open circle on the other end. It's a full line that has been cut off, because if this was the full equation, it would have arrows on the end, right? To let you know that it's a line that goes on forever. But this is not going to go on forever because it is part of a piecewise function. So they cut off part of it. And then lastly, you have this little dot right here. And it just says y equals 6. So this is actually a y equals 6 is a horizontal line. But because this is a piecewise function, they only took a piece of that horizontal line. And that piece of the horizontal line is just 1 point. Okay, and then when you combine these three graphs together, you end up getting your piecewise function. Okay, so what we're going to do is we're going to draw a piecewise function and then try to point out some of the characteristics. Okay, so let me scroll up and see. Here is an example of what a piecewise function may be written like. You know what, to make this a little bit more, let me separate this out a little bit. Okay, because I want you to clearly see the different parts on this. You are witnessing my editing here. Okay. So on this graph, this is a piecewise function, and this piecewise function is constructed with three different graphs. You have one right here. This is your first graph. You have one right here. This is your second graph. And then you have one right here. This is your third graph. And you're taking this graph and then restricting it based on what you see over here at the very end. Okay, this part at the very end is basically telling you how to cut off these graphs. And I'm going to show you how this works in just a minute. So let me erase this. And my suggestion to you is to look at this one at a time. I'm actually going to erase this also. So let's look at this first equation. Let's look at the one in blue. Let's make this all about blue. So blue, negative 2x plus 1. So what I'm going to do is I'm going to go to the side of my paper and I'm going to just focus on negative 2x plus 1 and graphing that on my xy plane. So I'm going to say y equals negative 2x plus 1. That equation is a line. I know it's a line because it's set up like y equals mx plus b. I just see x raised to the first power, and that kind of lets me know that I have like a line situation going on. So if I look at this, the way you graph a line is you have to first plot the y-intercept. In this case, your y-intercept is going to cross at 1. And then you need to use the slope. The slope in this case is -2. And you need to use the slope to get an additional point. -2 is the same thing as saying -2/1. So let's use these two things, right? I have the slope, I have the y-intercept. If I go to my xy plane, let me plot the y-intercept, which is going to be at 1 on the y-axis. So blue dot right here at 1. And then my slope is -2/1. So -2/1 means, because you know slope is rise over run. -2 means I'm going to go down 2, 1, 2, and then I'm going to run 1 in the positive direction. So here's my second point right here. I go down 2, 1, 2, run 1. Down 2, run 1. Down 2, run 1. Now, I could go backwards as well, right? And I will fall on the same line. Know that you can go backwards on this. I could go up 2 and back 1 and see I land on the same exact line. Go up 2, back 1. All of these points are on the same line. So now I'm going to use my app here to kind of make a straight line, because if I try to do this freestyle, it may not come out the way I want it to. Let me see if I can draw a line that goes all the way through these points. Okay, so that's my line, right? That's my full line. That's y equals -2x plus 1. Now, piecewise functions mean, okay, I draw the full line, but I go back up here to the top. This is the important part where I want to look at this. This part right here will tell you how to cut off that line. It says, I want you to draw the line -2x plus 1, but I only want it to go from -3 to 1. -3 to 1. So I go back to the graph and let me find x equals -3. -3 would be -3 would be right here in this area. -3. This point right here will be the -3, right? So I want you to start here, go from -3 to what was the next number, 1. So -3 to 1. So where is 1? 1 is right here. So here's the 1 and here's the -3 on the x-axis, right? So anything that's outside of these 2 points need to be erased. I only want the graph to go from -3 to 1. Anything outside, like all this stuff down here, needs to go. Anything outside, like all of this stuff, it needs to go. I only want to keep the stuff in between -3 and 1. So what I'm going to do is I'm going to use my eraser to erase all the part that I squiggly lined out, right? All this stuff goes away. Then up here, all of this stuff goes away also. Okay, and see, now I have the part of the line that goes from -3 to 1. So another thing we need to pay attention to is to, do I include a closed dot or a negative? Or a closed dot or an open dot, sorry. So when you look at this inequality up here, the first inequality says has less than or equal to. That means you should include that number. But then the second one is just a strict inequality that doesn't have that little bar underneath it. So that indicates that with the number 1, I'm going to have an open circle. So closed circle, let me go back to blue. Closed circle up here with -3 because it has an inequality with a bar underneath it. But with the 1, because the 1 just had a strict inequality with no bar underneath it, I am going to change this closed dot here to an open dot. Okay. And this is part one of my piecewise function, because this is only one equation that I have graphed so far. Okay, so let's move on to the next equation. Let's do this one in red. So this one is x squared. Do this one in red. Okay. And I'm gonna erase what I have here. So I have a place to put the red. So the equation now is going to be y equals x squared. Now I have to plot that. X squared, because you see x raised to the second power in your mind, you need to understand that that is a parabola, okay? And I can't just draw a freestyle parabola on this page. I can't just it has to be some specific points. So what I'm gonna do is I'm gonna make a T-chart. I don't know if you remember doing this back in the day, but a T-chart is where you pick some x values, you plug the x value into the equation. So I put -2 in for the x, and then I do -2 squared. -2 squared is going to give you +4. So you plug the x value in to find the corresponding y value. So when I plug in -1 into the equation, I get -1 squared is +1. I plug in 0, 0 squared is 0. I plug in 1, 1 squared is 1. I plug in 2, 2 squared is 4. So what I have here is basically 5 points that I can plot on my XY plane, and I'm going to do that to create my parabola. So let me plot these points. I have -2, +4, -2, 1, 2, 3, 4 will be right here. Then I have -1, 1 would be right here. Then I have 0, 0 would be right here. Then I have 1, 1 would be right here. And then I have 2, 4 would be right here. And so if I connect all these dots, it's going to make a parabola, right? Look. I have a parabola right there. So the red part that you see on the graph now is the full equation. But I don't want the full equation. I only want a piece of the equation. This is a piecewise function, right? So if I go back up to the original equation, this part tells me what to keep. It says only keep the x values that are greater than 1. Only keep the x values that are greater than 1. Okay, so I'm going to go back to the graph that I made, and I'm going to find x equals 1. X equals 1 right here on the graph. This is where x is equal to 1. And I only want to keep the x values that are greater than 1. Anything that's less than 1, like all of this stuff right here, the squiggly line, I don't want any of that stuff. That needs to go away. Okay? I only want to keep the stuff that's on this side because all of this is greater than 1. Okay? So let me erase the part. I want to erase all of the squiggly line stuff, right? And I'm going to try to erase this without erasing the blue part. And if I do, I can just go back and fix it. Okay? So I erased a little bit of the blue, but I can just go back and fix it. Okay, so at 1, should it be an open or closed dot? Open or closed dot at 1. Based on this inequality, because it is a strict inequality with no bar underneath it, it should be an open circle right there at 1. So in place of the closed dot that was there, I'm going to put an open dot. So this is the part of the function that is greater than 1. Okay, So I'm almost done. I got the first part, I got the second part. Now let's look at this last part. And we'll do this in green. It just has the number 2. Okay, so let's erase this. And let's put y equals 2, okay? Y equals 2 is a line as well. It's a special type of line. It's a horizontal line, actually. You go to 2 on the y-axis, which is right here, and then it will just be a horizontal line that goes all the way across like this. If I told you to graph y equals 2, that's what it would look like, the full graph. But again, this is a piecewise function. So I go back to where I have the graph, and let's see what restrictions I have here. It says I want the line, but I only want the line where x is equal to 1. I only want the line where x is equal to 1. So let's go to the graph and see if we can find that. Let's find x equals 1 on that green graph. Where is x equal to 1? Right here. This is the only place where x is equal to 1 at this particular point right here. So if it's not equal to 1, it's going to go away. Therefore, all of this stuff is going to go away. All of this stuff is going to go away. The only thing that I'm going to keep is that one point right there where it's equal to 1. So all of this stuff goes away because that's not x equals 1. All of this stuff goes away because this is not x equals 1. I got to erase this little part right here. Again, we'll fix the blue line. I only want to keep where x is equal to 1. So I can erase this whole thing and just put x equals 1, a solid point right there. And what we have done is we have completed our piecewise function. Okay, so now that we have finished the piecewise function, let's answer a few questions, okay? Because there are some questions we can answer about this. The first thing that they may do is ask you, what is the domain? And when they ask you what is the domain is always going to be what is the domain across all the graphs that are in the piecewise function. So when you look at a piecewise function, you're trying to determine what the domain is going to be. You need to think, okay, let's say if I had a ruler down here. I'm just going to draw a line down here and see if this could help us understand how to do. Okay, let's have like a little marker, right? So let's say we have a little marker down here. I'm trying to figure out what the domain is. Domain is always your interval of x values, right? So think about that blue line that I just drew down there as like a ruler. You're trying to figure out what's the very lowest x value that this graph takes up and what's the very highest x value, and are there any gaps? So when I look at this graph, I'm trying to determine, okay, are there any gaps, and what is the lowest and highest x value? So the very lowest x value that I see on here, when I think about this blue line, the very lowest x value, I see it starting right here. This is the lowest x value that I have. This is where this graph starts. And the value that I have right there is -3. And it is actually a closed dot. So this is going to be bracket -3. Okay, bracket because there's a closed dot there, meaning I include that number. Then let's go across. Okay, I have graphing here, I have graphing here, I have an open circle right here. But when I look up, even though I have an open circle right here and I have an open circle here, I have a closed dot right here at with the green graph. So that doesn't create a gap. in my interval, right? Because there is something that's taking up the space right there where those open circles are. And so I keep going across, I keep going across. Now, what's the highest x value? If you notice, I have an arrow right here, okay? And that arrow is going on forever. So my domain is going to go up to infinity. So this graph, let me erase all of my little doodles here so you can just see the piecewise function. Okay, so here's your graph. Make sure I fill in everything here. Okay, and I'm even gonna erase this little line that I have down here. So when you think about your domain, your very lowest value that you have here for your domain will be right here at -3. And then it keeps going across, keeps going across, keeps going across. Even right here, it has a point right there at the green. So it still keeps going across until it goes on forever going this way. Okay. So it's -3 to infinity. Now let's switch gears a little bit and let's talk about range, because range is going to be the interval on the y-axis. So we're kind of shifting gears, not looking across we're not looking across the x values, we're now looking across the y values, okay? So we're trying to see what's the very lowest y value and what's the highest y value. So if I look at this graph, the very lowest y value that I have here is going to start right here. This is the lowest y value that I have, and that is -1. It's -1, and it's also an open circle. So when I draw this, it's going to be parentheses -1. Now, let's see what is the highest y value. So it continues to go up, it continues to go up, and then I have an open circle here, but it doesn't matter because I do have the blue part that's filling in that open circle. It keeps going up, keeps going up, keeps going up, and it seems to keep going up forever. So it's going to be -1 to infinity. That's going to be your range. Okay, so let me erase all of the doodles. Get all the doodles out of the way. And let's look at this again. Your range, the very lowest y value is going to be right here at -1, and then it's going to continue to go up to infinity. Okay. All right. One more question it's going to ask is this piecewise function continuous? So the question, is a piecewise function continuous? It depends on if this graph is connected or not. So what I say is, when you trace over this graph, this piecewise function that we have created, if you can start on the left-hand side and draw all the way across this entire graph without picking up your pencil, then you say that it is continuous. With this particular graph, I can't do that. Because if I start over here with the blue, okay, I'm tracing here, I'm tracing here, I'm tracing here, but I have to pick up my pencil to continue to trace across the graph. Because this graph is not connected anywhere, I say that it is not continuous. Okay, not continuous. Now, if you have a graph where everything is connected, then you would have something that is continuous. That means you can go from left to right on the graph and not pick up your pencil. That's what continuous means. Okay. Another question I can ask about this is intercepts. If I have an x-intercept, your x-intercept will be the place where it crosses the x-axis. Your y-intercept will be the place where it crosses the y-axis. So you could get questions like that asked of a piecewise function. Okay. So I want to keep that in mind. So thank you for watching this video on piecewise functions.